Hi guys, welcome back to the channel. And we have here this Mercedes CLA 250, I believe, but this is valid for almost all of these Mercedes engines for those years, even probably up to 2018 or 19. This is the 4-cylinder, so this looks like it probably has the front wheel drive, because the engine is not facing the facing the firewall and the radiator, but it's actually sideways. So we have this infamous code here, P029921. That is the boost pressure of the turbocharger is too low, and I'm gonna show you how to try to diagnose this thing. So on this engine, this is where the turbo is, behind the shield, and you have the side, that's the exhaust side, and then you have the intake side. And the only way you're not going to have enough boost pressure is when something is wrong with the keeping of the actual pressure on this side actually here, because remember, it's the two sides spin, so it spins on the exhaust side and then it keeps on this side. Well, in our case, actually the boost pressure is on the exhaust side here, and what controls the boost pressure is actually this thing, this valve here. It's a vacuum valve, and it's called this is the actual wastegate pressure valve, because the wastegate inside, there's a little gate that opens and closes, so it keeps the actual pressure at a certain level when the turbo is still spinning inside and on the exhaust side. And under vacuum conditions, this line here is responsible for this wastegate. This rod here will move left and right, and it will either open or close that gate inside the turbo to keep up the actual pressure inside of the turbo, or this turbine that's inside the exhaust side. And the way to test this, so you have two parts that can fail on this side, and that's the one part is the actual wastegate inside the little kind of a door that opens and closes. It can get worn out with time, and I've seen those on BMWs and Audis. When they wear out, the metals inside start to kind of keep much bigger tolerance when it closes, so it doesn't really close enough, and then the boost pressure, it's not kept high enough because the gate is just not closed tight enough. So that's one thing that can fail. And the second thing is this here, because the gate is inside the turbo. We're going to test this one first, because this one could fail also. So the way this works is under pressure, and you need to disconnect this hose. You need to use a vacuum pump with a gauge and test it and try to see if this actually keeps vacuum, or if the valve actually keeps the vacuum properly and it moves. And you need to monitor this this rod here, that it needs to move to the left when it's when you apply vacuum. So here we go, it's actually moving, as you can see. And the only thing that I'm a little bit worried about is you see it's losing actually vacuum. So this is not good, because it's not supposed to lose vacuum like this. So that may be due to an internal failure of this valve inside. You see, we already lost a bunch of the vacuum. It's already falling down. This is a very similar test to the solenoids, the vacuum solenoids that you guys can do. And again, it's losing its value very fast. I'm gonna try to move it again. The actual wastegate is not moving, even though we're losing a little bit of vacuum here. So that may be okay actually. Yeah, it seems to be fine. So if you actually lose the value fast, then you're gonna have a problem. And in this case, it seems that this is fine. So this is one test that we can do. Remember, this is supposed to be vacuum conditions here, so you can try to trace this line where it goes and try to see if there's a problem with the line. Remember, these vacuum lines where you have rubber connections like these, they will fail with time and they will crack. So we can try to test this one and try to see where it is. It should be coming from a solenoid somewhere, and we can try to test the solenoid also, because again, we don't want to get into the turbo first. This side, the pressure on this side is actually controlled by the blow-off valve, which is electrical. So in this case, we don't need to test this because we're testing the actual turbo side here. So we're going to test this one, and possibly the last thing that we can do is we can test the blow-off valve and see what's going on with that pressure on this side. Okay guys, so as I was trying to explain to you, what we need to do in this case is follow the line, which is this line here, here, it's on the top, and when you see where it's going to the left side, so it'll always, you know, when you have a valve like this, vacuum line, you always either have a connection to to another solenoid, or you have a direct connection to a solenoid controlling this. And here we go, we have in this case this is the vacuum line again going to this solenoid right here, and we're gonna test this solenoid now, because this is the next step, because this is what controls the valve. This is what keeps the valve open, and we need to disconnect it here, and we need to disconnect the line here and try to apply. We're gonna apply 12 volts to the solenoid to try to you know, open and close, and we're gonna apply the vacuum line here. So when we apply the vacuum line, when this is closed, when we give power to this, when it's closed, the power line should be holding, or the vacuum should be holding, which means that the solenoid actually opens up the vacuum from the engine, sucking air, creating vacuum in the line, going to this valve, and then moving the valve in this direction to open it. We can also try to test this line. I'm a little bit not liking this line here. It's kind of loosely coming off. We're gonna try to test this a little bit also when I remove this, and here we go. So we need to pull this lock pin, and then you need to push the lock pin inside, so you remove the plug, and then we need to reach this line here where it goes inside the of the solenoid. Okay, and we put it. Now we can test and see if we are keeping a good vacuum. Okay, I need to get an adapter. Okay, we have an adapter. I'm going to connect it here, and I'm going to test and see, apply vacuum, and we need to see how this rod is going to move again. Okay, as you can see, it is moving. It's losing the pressure a little bit, but it's not that bad. It doesn't seem to be leaking here. It's kind of slowly losing the pressure as before. And what's most important is for you to see whether this rod moves or not. And you see it's not moving, so that should be okay. And I'm gonna release the pressure. And now we're going to test the actual solenoid for functionality. And remember, this is a test that can be done or should be done on any solenoid that actually is responsible for vacuum operation around the car. And there we go. Take this out, and we need to connect our line, the actual vacuum line of the tool. Okay. Doesn't need to be all the way in. You just need to get in a little bit in the beginning, so it actually keeps a little bit of a vacuum level. Okay, it's far enough. And now we need to get a 12 volts that we need to apply to this solenoid to check the vacuum. Okay, I don't know if you can see, but yeah, right there you have 2 prongs, so we have to connect two of these to get electricity to this. I don't have electricity yet. I'm just connecting these legs, and I am going to test it in a second. Remember, make sure that the 2 of these are not touching each other for obvious reasons. And now what we need to do, so I have connected plus and minus the 2 wires there, so I'm jumping the solenoid. Normally what you're supposed to do is you're supposed to pump like this and see, of course, if it's leaking. But remember, it's going to leak right now because it's not on. The valve is not on. I need to give electricity in order to test that this is working or not. So normally when you apply electricity, nothing should happen. You're supposed to only hear a click. But in our case, actually, I'm not sure how this solenoid works in this case, but it is creating vacuum immediately. It's gonna do the testing anyway, but normally what you're supposed to do is you're supposed to apply electricity. You're gonna hear a click there, and you're gonna see power to this, or creation of vacuum, or no, actually normally you're not supposed to see anything after you apply the electricity. Then you're supposed to apply vacuum and see what's going on. And in our case, I'm gonna apply the vacuum and see if it leaks. And it's actually leaking a little bit, so it's not supposed to be doing this. It's not supposed to leak like this. It is supposed to have a constant vacuum. So in this case, most likely the diagnostic would be the diagnostic points at a failing solenoid, and these are famous to fail. We just replaced on 2 different cars this past week solenoids because they fail. Okay guys, again, actually I just realized that I believe the reason why I was getting an immediate vacuum signature is because there was vacuum in the system, and we have electricity right now applied to this solenoid right here. So we're going to apply vacuum again, and I mean right away we see a failure. So this solenoid is not working. You see, it is not keeping vacuum. So this is where you start first with this solenoid, and then this should be the problem at this point, and then we're gonna go from there. But I believe this is the actual proper diagnostic, and this is what it's supposed to be. So again, if you have those codes, please do the troubleshooting correctly in order to figure out what part is failing. And I wanted to show you guys the actual part number on this, and the part number is right there. It's on the bottom right here. It's A0101531328. That is the part number of this solenoid that needs to be replaced. It's called a boost pressure solenoid, and again it's A0101531328. And I will include a picture of the part number with the proper picture when you're replacing this. Okay guys, again, thanks for watching. Please like my videos and please subscribe. Thank you. Thanks very much.